Hey everyone, and welcome to a new video on this channel. This time we'll talk about Azure Active Directory Pod Identity on Azure Kubernetes Service. And we'll use the Azure SDK for Go to illustrate how it works. Now let's set the scene first and see what we are going to do in this video. We are going to create a managed identity in Azure. We'll call that one RG API, and that identity has the contributor role on my Azure subscription. Next, we'll need some code. In this case, the code is written in Go, and this code needs to enumerate resource groups on the subscription. We'll use the Azure SDK for Go to enumerate the resource groups, and of course, we will try to authenticate to Azure using the managed identity called RG API. The code is available in a container on GitHub Container Registry. In order to do this successfully, we need to deploy Azure Kubernetes Service with the AAD Pod Identity preview, and we'll also need to use Azure CNI networking on that cluster. The cluster I'm going to create will have 3 nodes. And the use of AAD Pod Identity results in NMI pods on every node. NMI stands for Node Managed Identity. And it basically takes care of providing our application that requests a token to authenticate with this token. Then of course we need to run our code as a container. I'll call it the app container. And we need to tell this container that it needs to use the pod identity that we will associate with the managed identity in Azure. We'll do so by creating an AAD pod identity on the cluster. And in that pod identity object, we'll refer to the resource ID of our managed identity. And of course, the app container, the YAML spec of what we'll deploy on the cluster will refer to the container that's up on GitHub Container Registry. Now, all of this code is available on GitHub. Just go to github.com/gebake in the Go MSI repository. And if you want to use the container just like that, you can use the GitHub Container Registry container version 0.1.1 currently at the time of creating this video. All right, let's get started getting our hands dirty. We will start by creating our AKS cluster first. I already created a resource group called RG Clue ID in West Europe. And then I'm creating a simple AKS cluster that only has the necessary settings to enable managed identity and pod identity. So we do AZ AKS create, we use the resource group, the name of the cluster. I've also set the version of AKS to 1.19.3, which is the currently the last available version in West Europe. And then to enable pod identity via the add-on, which again is in preview today, you have to enable managed identity and then you enable the pod identity. By the way, you also require the network plugin to be Azure. So let's start this command here. Let's run it. And we'll wait a moment until this finishes. The command has finished running. So I'm now going to get the credentials to this cluster. So we run AZ AKS get credentials. Then we use the name of the clusters. That's this name over here. And then we use the resource group, which is RG Clue ID here. So we copy that as well. And this gets the credentials to the cluster. Now, I already had them before, so I'm going to overwrite this. Let's clear this screen. And let's do a kube control or kubectl get nodes command, which in my case is alias 2k. So k get nodes. Yeah, if you get this and you're running WSL 2.0, you should do time and date synchronization, or better said, time synchronization. So just use the ntp date command. So ntp date, then use the time.windows.com or another time server to synchronize the time on this WSL instance. Once that is done, the time will be correct for the certificate to be recognized properly, so we can use kget_nodes. With these nodes running, we can now run K9S. Already did that. And what you'll see here is that there are a couple of pods running here, which are the NMI pods. And the NMI pods are basically part of a daemon set. So on each node of the cluster, you'll have an NMI pod. Now this NMI pod is important because when you're going to use pod identity, or you want to use managed identity from within a container running on a node, you're going to do a request to a specific IP address, and that should be intercepted. It's done by a route table modification by this NMI pod. So we'll see later when we run some code that is using managed identity, we'll check the node that the code is running on. Then we can check the logs of the NMI pod to see if it has indeed intercepted the call and can provide the token to the caller. But that's for later. But important here is, after you've installed your cluster with pod identity, make sure you double check that you have the NMI pods running on your machine. Next, we will need a managed identity that our code is going to use to do its work. I'm going to use the RG API managed identity that you see here. I created it in a resource group called RG Clue MSI. You can see that the type is of the user assigned managed identity type, and some useful information such as the client ID or app ID is also shown here. Now for later, it's important that you know where to find the resource ID. The resource ID will be required when we create the pod identity at the Kubernetes level. So you can find this in the properties here in resource ID. So you should copy that somewhere so you can easily use that later. Now to create a managed identity, you would just click Add, select the resource group where you want this identity to be created. And in my case, I'm going to use West Europe. I give this a name, for example, MI test. And then in the next step, I can add some tags, and then I go to review and create, and I create the managed identity. So it's very simple to create a managed identity within the portal. Of course, it is important once you have the managed identity created that this identity has the required access rights that your code will need. For example, if you want to list resource groups, you'll have to make sure that this identity has the right to read resource groups. Now you can do this from the subscription level, for instance, but there's also an Azure role assignments here, which is in preview, but it should work. There you can click on plus, select the scope, for my case, for instance, subscription, select my subscription, and then select the role. If I want this identity to also create objects in my subscription, I would give it the contributor role. Then just click save and you're done. Now I'm not going to do that. I already have my identity for now. If I'm going back to the managed identities in my subscription, and I'm going back to the RG API, and let me first delete the sample that I've shown you earlier. If I'm going back to my RG API managed identity, you will see that it already has this Azure role assignment. So it has contributor on the subscription, and it's assigned indeed to the RG API managed identity. With the managed identity created in the Azure portal or via the CLI, we now can add the pod identity to our Kubernetes cluster. So we use the AKS pod identity command for this. We'll use the add verb to add the pod identity. Of course, our cluster is still in the resource group rg-clue-id and the cluster name is clue-id. The command needs to know on what cluster you want to add it. And this identity will be created in a namespace. The namespace is called my_MSI. You don't have to create this namespace in advance. The pod identity itself is called my_MSI as well. This could be a different name. And of course, we need to link this pod identity to the managed identity in the cluster. That's done with the identity resource ID parameter. And as we just discussed, you need to use the resource ID to the managed identity here. So let's run this command and see what happens. And of course, you need to make sure that your kubectl command is connected to this cluster. Let's see what happens. Yeah, so indeed, he's creating the managed identity, but he's waiting a while for the Azure AD role propagation to occur. So let's give it some time and then we'll come back to this command. Now, with this pod identity created, that means something must have happened on our cluster. Let's take a look at our namespaces. So with kgetNS, we'll see the namespaces, and indeed, 59 seconds ago, there was a new namespace created called my_MSI. Let me just go into that namespace with kns my_MSI. And yes, I have a plugin installed, a kubectl plugin called ns. I installed that with crew to set the current namespace to the one that I select here. So with kns my_MSI, I'm now within this as my default namespace. I can now do kget_crd, and in this namespace my_MSI, there should be an Azure identity. So if I'm doing kget Azure identities, I should see the my_MSI identity. That's the one that got created with the command you see over here, right? Now, if we describe this Azure identity, we can clearly see that in the spec, the client ID of my managed identity is recorded, but also the resource ID is properly recorded. So this is my managed identity that was created. Now, if you look at the CRDs again, you will see that there's also a Azure identity binding. Let's take a look at what bindings were created. So kget Azure identity bindings. Indeed, there's a my_MSI binding. Let's describe this my_MSI binding, or this Azure identity bindings. And we'll see here in the spec that this just says, well, the Azure identity is my_MSI and the selector is my_MSI. Now we need to run some code on the cluster that is using the AAD pod identity binding that we just created, and we need to refer to our my_MSI pod identity here. So what you can do, for example, is create a regular deployment. The deployment deploys pods, and in the template of the pods, or better said, in the metadata of the pod template, you'll need to specify in the labels this special label called the AAD pod ID binding. And of course, you refer here to, well, not actually the name of the binding, but you refer to the name of the pod identity, which, if you remember, in our case is my_MSI. Now, of course, then we need to run some code that is taking advantage of managed identity and doing some calls to the managed identity endpoint in order to properly get a token for this identity that we refer to over here, that has the necessary access rights to, in our case, list resource groups in a subscription. Now, my code requires that an environment variable called subscription ID is set. And of course, the value needs to be the actual subscription ID. There are some optional variables that you can set, such as the Azure Client ID, which would be the app ID of your managed identity, or the Azure AD resource that you want to authenticate against. Now, in this case, these two environment variables are not required. The Azure Client ID, if you do not specify it, will be automatically matched to the client ID of the pod identity that you refer to here with my MSI. And the default Azure AD resource that you work against will be management.azure.com. Now, before we look at the code, I'm just deploying a container here called Go MSI version 0.1.1. So I'm going to deploy this container or this deployment and see if pod identity is actually working. To deploy the container, I'm going to use the kapply-f command here. So let's just run this, and indeed this should create the MSI deployment. So with the deployment finished, I now have a pod running, which I'm showing with K9S. And let's first look at where the pod is running, on which node is it running. It's running on the node that ends with a 2. We'll need that later when we check our NMI pods. Now, in this case, this pod should have used the pod identity to properly authenticate to Azure AD and then retrieve a list of resource groups. Let's check this. Let's show the logs. And indeed, you can see that the application was able to authenticate successfully, and that the true test, of course, is in can it show the list of resource groups in my subscription. And note that I provided my subscription by providing a subscription ID environment variable. If I exit the logs of this pod and I'm going to all my namespaces, we can check out the NMI pods. The NMI pods, of course, every node has one. In this case, I should use the one on the node that ends with 2, because that's where my pod identity pod was running. If I ask for the logs here and I check them all and I set word wrap here, let's just look at the latest logs. I'm seeing here that the last request that I did for a token for my managed identity, the NMI pod could see that I sent a client ID in the request. I asked for a specific client ID. As I said earlier, that is not really necessary. If you don't specify this client ID environment variable, this line will be missing from the logs. What you will see though is that there will be a match, automatic match made with the pod identity that you refer to in your deployment manifest. So in this case, you see, well, I matched an identity with client ID A3A7. That's indeed how my client ID of the RG API managed identity, how it starts. And this is one which is going to authenticate to https management.azure.com. So a token was requested to authenticate against this endpoint. The token must have been successfully delivered. You see here a status 200 for the request that my application made on this endpoint over here. So that's how we can verify that indeed the NMI pod has intercepted the request for a token from my application pod and that the result was successful. Now you can also see that I had a status 400 before. Sometimes requests to this endpoint might fail. Your code should take that into account and maybe retry the request. I don't have that built into my code. So if that happens, I need to restart the pod. Now we can look at the Go code that uses managed identity. We of course need two packages. That's the resources package, which allows us to do things like enumerating resource groups. And we need the auth package from the Azure SDK for Go. Now I'm not going to go over all the lines, but a couple of things I need to point out. First of all, I need a subscription ID that I need to pass to a method later on. I get that from an environment variable. To enumerate the groups, we're going to use a groups client. Now the resources package has a new groups client method that takes the subscription ID as a parameter. course, the groups client needs to be able to authenticate. So to actually get an authorizer, we call the new authorizer from environment method from the auth package. Now, this method is, of course, where the magic happens. This method allows multiple methods of authentication, and managed identity is just one of those. And this method depends on all sorts of environment variables being set in order to pick the right one. Because I didn't set environment variables, for example, that do service principal authentication, it should at the end, at the last step, try and use managed identity. Now, although I'm doing here some error checking, you'll notice that if you would run this code, auth is pretty much successful all the time, which does not mean that managed identity will certainly work. The call to get a token from the managed identity endpoint, so to speak, can still fail later on. So auth will pretty much all the time be successful. Good. We are then assigning the authorizer we got to the authorizer of the groups client, and then we can use the groups client, the list complete method, to get a list of resource groups. And here we are just iterating over the resource groups with a for loop for groups.notDone. What we do here is we have a slice, a global slice variable, and we append the name of the resource groups. We append that to that slice. That slice is later served, you can see here, by an HTTP server. It's later served by this endpoint, so to speak, the /groups endpoint, and the groups function is actually serving the content. If we're going to that function, you'll see it's just a normal HTTP handler, nothing special, and there we are sending over the groups list after, of course, doing a JSON marshal. So that's the Go code. Of course, we also need to build a container from this. In the GitHub repo, you will find a Docker file. I'm not going to go in detail about this Docker file, but there are a couple of things that are important. First of all, I'm going to build a static executable. You're going to see that here. And this static executable can be put in a Scratch image. Now, the Scratch image is a special type of image, which is basically 0 bytes. So the only thing that's in the image will be the app that we copy from our build container to this Scratch container. And that's a problem, because the code is going to do a call to https management.azure.com, and it will need to be able to verify the certificate that it gets from that server. So you need the certificate authority certificates in this Scratch container. That's why, and that's quite important, we are in the build container, we run this command to install the CA certificates, and then in the Scratch container, we are later copying them from the build container to our Scratch container in this folder. Now, the actual container image that I built is done using a GitHub workflow. Don't worry about that one, but it means that you will be able to get the image from this image here, this image tag. So the image is up on the GitHub container registry, so ghcr.io, g/go msi. And yeah, of course, you can use latest here if you really want to. And at the time of this writing, I think the last version that was pushed, the most recent version that was pushed, that uses the code that you've seen earlier in main.go, is version 0.1.1. All right, we have come to the end of this video in which we have shown how to use AAD Pod Identity on AKS in combination with some Go code that is using the Azure SDK for Go. I hope you liked it, and of course, if you have remarks or questions, do leave them in the comments. Bye bye and take care.